Hi students, so this is Umameshwar once again in front of you to do the chemistry classes. Today we are going to learn alkanes, preparations, physical properties and chemical properties. First I go for that one, just a revision of that alkanes. Alkanes are also called as what? Saturated hydrocarbons, or also called as paraffins. Para means little, affins means reactive, saturated hydrocarbons. General formula is CnH10 plus 2. Instead of N, you substitute that carbon atom 1, carbon atom 2, carbon atom 3, 10. Then you can get the compounds like methane, CH4, ethane, C2H6, propane, C3H8, butane, C4H10, pentane, C5H12, hexane, C6H14, heptane, C7H16, octane, C8H18, nonane, C9H20, then decane, C10H22. So that's the members of. First we are going to learn that the methane structure of methane is there. This is already you learnt in the last class. Here is the structure of methane, one carbon atom and four hydrogen atoms. Here is the center carbon atom and the four hydrogen atoms are bonded with the H is in the spherical shape, and then the P is and here's and the dumbbell shape is there, and sigma bonds, four sigma bonds at the four corners, and we come for that one, the planar and spatial arrangement representations of methane. Observe the planar and spatial arrangement of this. Again, once again, you learn that one, the carbon is 1 and then hydrogen is 4, methane structure again carbon 1 and then methane. Observe that the spatial and planar arrangement of the structure. So this is the initiation of that alkanes. Next we come to that one, preparation of alkanes. How do you prepare alkanes? Preparation of alkanes is done by, the first one by alkenes. What are alkenes? You know in the 10th standard, hydrocarbons, saturated hydrocarbons. So those are coming from Kannada medium, saturated, santrupta dramana anta, santrupta hydrocarbon. Single bond idre adu saturated hydrocarbons. Methane, ethane, propane, butane ಎಲ್ಲ saturated. ನಾವೇನು ಮಾಡ್ತಾ ಇದೀವಿ ಈಗ alkenes, double bond ತಗೊಂಡಿದ್ದೀವಿ. This is an alkenes, unsaturated hydrocarbon. This is also unsaturated, triple bond. So that's why from alkenes and alkynes. So when we add hydrogen to the alkenes, again we get alkanes. Again triple bond, acetylene, C2H2, then hydrogen is that, again we are going to get alkane. But in this method we are not going to get methane, because methane is only one carbon atom and four hydrogen atom. We cannot prepare by this alkanes and alkynes. The methane cannot be prepared by this method. So come to that one. Another method is there from alkyl halides, RX. R is alkyl group, meth, eth, prop, but, pent, hexa. That's about that, hexa, hepta, deca. Then what it forms here, this is the skeletal structure is there, RX, alkyl halide. X is in halogens. Halogens are fluorine, chlorine, bromine, iodine, astatine. You know that the periodic table, the members of the halogens are called X. Those are called what? Halogens family. Then again that alkyl halides treated with sodium in dry ether, it forms alkanes. This is reaction is called Urids reaction. Again we come to that one. The another one, the specific reaction is there, methyl bromide. 2 molecules of methyl bromide plus Na, it forms in dry ether. Again ethane plus sodium bromide. Same type, when ethyl iodide is treated with 2 ethyl iodide molecules treated with sodium, it forms butane. 2 ethyl forms butane. 2 methyl forms ethane. 2 methyl CH4 CH4 becomes CH3 CH3, that's a single bond. CH4 CH3 CH3 becomes C2H6, that's a single bonded carbon atom. Then we come to that another one, another reaction. Similarly we go for that one, ethyl iodide. But it is a good method for the preparation of what? Symmetrical alkanes. Symmetrical alkanes andre symmetrical, they should have that one, the same structure but not the branched and other things. So methane cannot be prepared once again. That is, and wherever the chemistry is there, there is an exception. There is an exception for the chemistry. So here's about by reduction of alkyl halides. Again, how do we prepare the alkanes? By the another method, by reduction of alkyl halides. I told alkyl halides is RX, alkyl halides with nascent hydrogen. Observe here. And the second one is an action of ethyl alcohol and zinc copper couple. So now we come to that one, zinc and hydrochloric acid, it forms zinc chloride, and hydrogen. Nascent hydrogen it forms. This is called nascent hydrogen. When nascent hydrogen is treated with RX, alkyl halide, ಬರ್ಕೋಬೇಕಿದು. If you don't understand, write it please. I request you students, write down these things, whichever you not understand. Just not only switch on that the mobile and then sit without pen and other pencils and then the books. You cannot understand. Go on, write and write. Take the book, sheets, color pencils or color pens, write it. Wherever the word you don't know, start to write it. Nascent hydrogen, it forms RH. Again it forms an HX. This is skeletal. Instead of this one, we can take an R, methyl bromide and hydrogen. It forms an methane plus one hydrogen. It becomes a methane. This is the one reaction for the alkanes. The similarly, we go for the another reaction is that another preparation for the alkanes. Here's an after I come to this one. Here's a methyl iodide. Observe here. Ethyl iodide plus nascent hydrogen. Nascent hydrogen. What it forms here? C2H6. Here we have taken C2H5 plus 1 and 1H goes with the C2H5 and another H is with iodine, hydrogen iodide. Similarly, we can take that one. This is a formation of nascent hydrogen here. Here's a nascent hydrogen. Again, the nascent hydrogen is going to react with ethyl iodide plus hydrogen. What it forms? Ethane plus hydrogen iodide. And with hydrogen in presence of catalyst, same type, you take RX, ethyl bromide plus hydrogen. It forms again ethane in presence of PT, platinum, or PD, palladium, and HBr, hydrogen bromide. Hydrogen bromide, it is an HBr, not HBr. Hydrogen bromide, HBr. With HI, hydrogen iodide in presence of red phosphorus, then also it forms alkanes. Observe here, alkyl halide, ethyl iodide plus hydrogen iodide at the presence of 420 Kelvin temperature, it forms ethane and iodine. This is about the another methods of preparation. From monocarboxylic acid, once again you remember that the functional groups, dear students, because of the first year you may not know about the functional groups. First you go for functional groups. Before that I want to tell you functional groups. Alcohol is a functional group, acid is a functional group, aldehyde is a functional group. That is in the 10th standard. Once again I tell you, alcohols OH group, aldehyde CHO group, and acid COH group. Now we are taking monocarboxylic acids by decarboxylation. Observe the term. What is meant by decarboxylation? Agar decarboxylation then D andre removal, carboxylation. So we are removing the carbon dioxide. That's about the removing the carbon content or carbon compound. That's called decarboxylation. Observe here. Here we have taken acid or COH. This is a methonic acid, ethonic acid, propanic acid, whatever acid you want to take, plus NaOH, it forms RCONA, sodium salt, it forms first in presence of calcium oxide and 630 degree Kelvin. Again, sodium salt treated with NaOH, it forms RH and CONA, and Na it becomes Na2CO3. This is the decarboxylation of monocarboxylic acids. Then also we are getting alkanes. We should remember till we complete, we should remember that when alkanes our members, we are going to prepare them. So don't forget that one, what we are preparing, alkanes. Till you are finishing, that alkanes should be in your mind. Alkanes should be in your mind. Alkanes, single bonded. You go all the reactions, single bonded, alkane is there. Then we come to that another one. Same type, another reaction is there. Acetic acid plus sodium hydroxide in presence of same calcium oxide and 630 degree. Here temperature is riser than no 630. It forms sodium acetate and water. Again sodium acetate with sodium hydroxide in presence of calcium oxide. It forms what? Methane and sodium carbonate. Here NaOH and CaO, it forms a one compound. That compound name is called soda lime. In examination you are asked one question, what is meant by soda lime? Here's an answer. Soda lime is a mixture of sodium hydroxide and calcium oxide in the ratio of 3:1 at 630 Kelvin. That is a soda lime. Are you clear? So what are the different methods we learned, dear students? Just recall that one. First one, alkenes, then alkynes, then after that one RX, alkyl halides with nascent hydrogen, then acids. That's about the monocarboxylic acid. Next we go for another one. Decarboxylation reactions continues here. Go for that, the decarboxylation reactions. Next we go for that one. This reaction is given by the naming reactions by coal-based electrolysis method. Sodium salt plus water, it forms again ethane and sodium hydroxide and carbon dioxide and hydrogen. This is called again the decarboxylation reaction. Now we come to the properties of alkanes. I think you are correctly understand then following very interestingly. Is it? If it is not, then you go for that one. I explained that one. Those are coming from Kannada medium. I want to explain you two. Then I come to this one. After this, the alkanes I am going to explain you in Kannada medium, the fine Kannada language. So come to this one here. Carbon. So you can understand easily because you know that one. Try to understand in English because it is easy to write in English. But when you learn Kannada, bi-language will lead you difficulty. So come to the physical properties. From carbon 1 to carbon 4 are gases. They are colorless and odorless. What is colorless? We can understand that one. Water is a colorless. So that we can say that one, that colorless. In chemistry, the compounds like the sugar is a colorless, but it is in white color. We can mention that's not that one. It is a gases, colorless and odorless. No smell at all. Smell at room temperature. Again, above 5, above 4, that's up to 5 to 17, they are colorless liquids. Then higher members are waxy solids. Here is the nature of the alkenes. Nature andre enali solids, liquid, gases yavudagutte. अगर फर्स्ट कार्बन 1 ಇಂದ ಕಾರ್ಬನ್ 4 ವರೆಗೆ ಗ್ಯಾಸಸ್ ಇರುತ್ತೆ, ಕಲರ್ಲೆಸ್ ಇರುತ್ತೆ ಮತ್ತು ಓಡರ್ಲೆಸ್ ಇರುತ್ತೆ. ಅಗೈನ್ C5 ಇಂದ C17 ವರೆಗೆ ಹಾಗಾದರೆ ಕಾರ್ಬನ್ ಆಟಮ್ ಪೆಂಟೇನ್ ಇಂದ 17 ಕಾರ್ಬನ್ ಆಟಮ್ ಹಾಕಿದ್ರೆ ಇನ್ನೊಂದು ಕಾಂಪೌಂಡ್ ಬರುತ್ತೆ, ಅಲ್ಲಿವರೆಗೂ ಏನಿರುತ್ತೆ ಲಿಕ್ವಿಡ್ಸ್ ಇರುತ್ತೆ. ಮೋರ್ ದ್ಯಾನ್ 17 ದೇ ಆರ್ ವ್ಯಾಕ್ಸಿ ಸಾಲಿಡ್ಸ್. ನೌ ವಿ ಕಮ್ ಟು ದಟ್ BP, ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಆಫ್ ಆಲ್ಕೇನ್ಸ್. Generally alkanes have lower boiling point and branched chain, and alkanes have less boiling point to straight chain. Branched chain have less boiling point than the straight chain. When you compare to that one, when generally alkanes have lower boiling point, then we come to that one. Alkanes, what are the reasons for that one? Alkanes are polar, non-polar molecules. They are held with the weak van der Waals force of attraction between them. So observe this here. We are taken that one alkanes, and here's a C3H8, C3 propane, C4 butane. Recall this, dear students, don't forget. C3H8, C4H10, pentane, butane, C5H12, pentane, C6H14, hexane, heptane. Observe the boiling point. The boiling point of propane is 231. Again, butane is 273. Pentane is 309. Hexane is 342. Heptane is 371. And octane is 399. Every rise of the temperature is 30 to 40 degrees. That's 331 to 73. Again 73 to 309. Like that's a vary in the boiling point also, dear students. I think you're going to say yes or no. So if you are learned well, go through that one. Give the comments how much you have learned. What are the doubts you have in that? The same one you frame the questions in WhatsApp and other things also. And even then subscribe it. And whenever you want, you can see this one, see the lessons, and again go through that preparation of the notes. Please prepare notes. Take the notebook, take the pen, and sit, learn and learn and learn. Then only it comes. Come to that one. What happens in the branched chain and the straight chain? In branched chain, the carbon atoms tend to come closer, decrease the molecular size. There is one question is there. Illond question ಕೇಳ್ತಾರೆ. Branched chain ಮತ್ತು straight chain ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಹೇಗೆ ವೇರಿ ಆಗುತ್ತೆ? ಬ್ರಾಂಚ್ಡ್ ಚೈನಲ್ಲಿ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಕಡಿಮೆ ಇರುತ್ತೆ ಸ್ಟ್ರೈಟ್ ಚೈನ್ಗಿಂತ. ಯಾಕೆ ಅಂತ ಕೇಳಿದ್ರೆ, ಇನ್ ಬ್ರಾಂಚ್ಡ್ ಚೈನ್ ದ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಟೆನ್ ಟು ಕಮ್ ಕ್ಲೋಸರ್, ಡಿಕ್ರೀಸ್ ಇನ್ ಮಾಲಿಕ್ಯುಲರ್ ಸೈಜ್ ಆಸ್ ವೆಲ್ ಆಸ್ ದ ಸರ್ಫೇಸ್ ಏರಿಯಾ, ಡಿಕ್ರೀಸ್ ಇನ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸ್. That's why the boiling point decreases in branched chain than straight chain. Come to that one, chemical properties of alkanes. We have 3 chemical properties: halogenation reactions, oxidation reactions, aromatization reactions. There are 3 types of the reactions are there: halogenation reactions, oxidation reactions, aromatization reactions. Halogenation reactions, what are the halogenation? Again we know that one, halogenation. What is an halogenation? Again with halogens, fluorine, chlorine, bromine, iodine, astatine. But we are not taking fluorine and astatine. Fluorine is highly reactive, astatine is rarely available in presence of ultraviolet rays at the temperature of 520 to 670 degree Kelvin. It formed that one. First you go for chlorination. What is chlorination? Chlorination means the formation of the chlorine with continuous chain of alkenes. Take that methane plus chlorine. It forms methyl chloride in presence of sunlight, diffuser sunlight, and the temperature is 520 to 670 degree Kelvin. It forms methyl chloride. Here, for next step, listen, dear students. You have to write, ಬರ್ಕೊಂಡು ಮಾಡು, practice ಮಾಡಬೇಕಿದು. Again, methyl chloride with chlorine. Again, it forms what? Losing one more hydrogen atom from the methyl chloride, it forms dichloromethane. Again, the dichloromethane loses one more hydrogen atom, it forms trichloromethane. Again, trichloromethane we have taken, it forms and loses another hydrogen atom, it satisfies the 4 chlorine atoms, carbon tetrachloride. This reaction is chlorination of methane. First one, methyl chloride, dichloromethane, trichloromethane, and carbon tetrachloride. Trichloromethane is also called as another name called that's what? Formalin, chloroform, CHCl3, that's called chloroform. That's called chloroform. So this is about the chemical reactions of that one. Then after this one, we are going to take that one, another one. Then what happens here in that the 7, as the chlorination, we take bromination also. The bromination takes place in the same way, not easy, but we make that the next steps. Iodination of alkanes is reversible nature. Methane plus iodine gives rise to methyl iodide and hydrogen iodide. Again, methyl iodide and hydrogen iodide reacts with bonds, forms that one, methane and hydrogen. So this is about how the things are going to be in the chlorination and the bromination. Go for what is the mechanism is there. This is also very important for the examination view, because you have less number of chapters. These questions are supposed to be focused for the examination. Mechanism of halogenation takes place in 3 steps. The first one is chain initiation. Chlorination of methane takes place, halogenation of reaction takes place in the 3 steps. The first step is in chain initiation, or it forms the free radical in presence of what? Ultraviolet rays. See, X and X halogens are there, halogen forming free radical. This is the first step. Go for second step. Chain propagation. Propagation means increasing in size. Free radicals attacks and then alkanes, which also undergo that homolysis division to form methyl radicals and hydrogen acids. So then after this one, the third step is in chain termination. That comes under the third reaction. So just remember, students, don't forget to follow the steps. The first one is chain initiation, chain propagation, and chain termination. So write. Kannada medium student, please follow that one. Have the textbook, get the pens, and sit in front of that one. Open the video, do and redo. Then practice, you will get it. So this is another reaction. Then the last one is called what? The nitration of alkanes. What are the nitration of alkanes? Again, the nitric acid is going to combine with the nitration of alkanes. Just I take the break for this one, nitration of alkanes, and I continue this one from nitration of alkanes. Take that because it's an 18 minutes video. 18 minutes, 30 seconds have been finished. Just to go through. Once again, I come to you. Once again, you be with us.